Now we shall move on to the first question in the exercise. The first question is, write the following in decimal form and say what kind of decimal expansion each has. So let us take the first bit. Here we need to find the decimal expansion for 36 divided by 100. Since 36 is divided by 100, which has 2 zeros, we move the decimal point towards the left to 2 places, that is 0.36. Hence, the decimal expansion of 36 by 100 is equal to 0.36. 0.36 is terminating decimal expansion. Now let us move on to the second bit. Here we need to find the decimal expansion of 1 upon 11, that is 1 is divided by 11. So 11 does not go in 1, so we take 0, as 11 times 0 is 0. The remainder is 1. Since 11 does not go in 1 again, we take a decimal point, so 1 becomes 10. Again, 11 does not go in 10, therefore we take a 0, as 11 times 0 is 0. Therefore the remainder is 10. Now because of the decimal point, 10 becomes 100. Now 11 goes in 100 9 times, as 11 times 9 is 99, and we have the remainder 1. So because of the decimal point, 1 becomes 10. So 11 does not go in 10 again, so we take a 0, as 11 times 0 is 0. The remainder is 10. So because of the decimal point, 10 becomes 100. 11 goes in 100 9 times. So 11 times 9 is 99, and we are left with remainder 1. So from this division, the process continues as the remainders are repeating. Therefore, the decimal expansion for 1 by 11 is equal to 0.0909 and so on, as the digits 0 and 9 are repeating. Therefore, the decimal expansion is non-terminating but repeating. Now let us move on to the fourth bit. Here we need to find the decimal expansion for 3 upon 13. So we divide 3 with 13. Since 13 does not go in 3, we take 0. So 13 times 0 is 0, and we are left with the remainder 3. 13 does not go in 3 again, so we take a decimal point. 3 becomes 30. And 13 goes in 30 2 times. So 13 times 2 is 26. And we are left with the remainder 4. So because of the decimal point, 4 becomes 40. 13 goes in 43 times, as 13 times 3 is 39. We are left with remainder 1. 13 does not go in 1. So because of the decimal point, 1 becomes 10. 13 does not go even in 10. So we take 0. 13 times 0 is 0. Therefore we are left with remainder 10. Because of the decimal point, 10 becomes 100. 13 goes in 100 7 times, as 13 times 7 is 91. We are left with remainder 9. So because of the decimal point, 9 becomes 90. 13 goes in 96 times, as 13 times 6 is 78. And we are left with remainder 12. 13 does not go in 12, and because of the decimal point, 12 becomes 120. And 13 goes in 129 times, as 13 times 9 is 170. And we are left with the remainder 3. Since 13 does not go in 3, and because of the decimal point, 3 becomes 30. So 13 goes in 32 times. 13 times 2 is 26, and we are left over with remainder 4. Because of the decimal point, 4 becomes 40. 13 goes in 43 times. So we have 13 times 3 is 39, and we are left with remainder 1. Because of the decimal point, 1 becomes 10. 13 does not go in 10, therefore we take 0. 13 times 0 is 0. We are left with remainder 10. Since 13 does not go in 10, we take another 0. Because of the decimal point, 10 becomes 100. So 13 goes in 100 7 times. So we have 13 times 7 is 91. We are left with remainder 9. Because of the decimal point, 9 becomes 0. 13 goes in 96 times. So we have 13 times 6 is 78. The remainder is 12. Because of the decimal point, 12 becomes 120. And 13 goes in 129 times. So we have 13 times 9 is 117. And we are left with remainder 3. When we go on solving the process, the remainder repeats itself. Therefore, the digits 230769 are repeating. Hence, the decimal expansion for 3 by 13 is equal to 0.230769 bar. Here, the decimal expansion is non-terminating but repeating. So now let us move on to the fifth bit. Here we need to find the decimal expansion for 2 by 11. So let us divide 2 with 11. So 11 does not go in 2. So we take a 0. 11 times 0 is 0. So the remainder is 2. 11 does not go in 2 again. So we take a decimal point. So 2 becomes 20. 11 goes in 21 times. As 11 times 1 is 11. We are left over with remainder 9. Because of the decimal point, 9 becomes 90. 11 goes in 98 times. As 11 times 8 is 88. Now we are left over with remainder 2. Because of the decimal point, 2 becomes 20. Again 11 goes in 21 times. As 11 times 1 is 11. And we are left over with remainder 9. Because of the decimal point, 9 becomes 90. 11 goes in 98 times. As 11 times 8 is 88. And we have the remainder 2. Doing this process, we go on getting the reminders repeated itself. Therefore, the decimal expansion for 2 by 11 is 0.181818 and so on. That is 2 by 11 is equal to 0.18 bar. Here the decimal expansion is non-terminating but repeating. So now let us move on to the last bit of the question. Here we need to find the decimal expansion for 329 upon 400. That is, we divide 329 with 400. Since 400 does not go in 329, we take 0. 400 times 0 is 0. So the remainder is 329. 400 does not go in 329 again. So we take a decimal point. 329 becomes 3290. It goes in 3298 times. As 400 times 8 is 3200. So here we are left over with remainder 90. Because of the decimal point, 90 becomes 900. 400 goes in 900 2 times. As 400 times 2 is 800. Now we are left over with remainder 100. And because of the decimal point, 100 becomes 1000. And 400 goes in 1000 2 times. As 400 times 2 is 800. The remainder is 200. And because of the decimal point, 200 becomes 1000. 400 goes in 2000 exactly 5 times. As 400 times 5 is 2000. And we are left over with remainder 0. Hence the division stops here. Therefore, the decimal expansion for 329 upon 400 is equal to 0.8225. Here the decimal expansion is terminating. Now let us move on to the second question. The question is, You know that 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without actually doing the long division? If so, how? So we shall move on to the solution. So given is 1 by 7 is equal to 0.142857 bar. Here we can predict the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 without actually doing the long division. This is by the decimal expansion of 2 by 7 can be obtained by multiplying 2 with 1 by 7. That is, we need to multiply the decimal expansion of 1 by 7 with 2, which is 2 times 0.142857 bar. So 2 times 0.142857 bar gives 0.285714 bar. Hence the decimal expansion of 2 by 7 is equal to 0.285714 bar. Similarly, we obtain the decimal expansion of 3 by 7 by multiplying 3 with 1 by 7. That is 3 times of the decimal expansion of 1 by 7, that is 0.142857 bar. This gives 0.428571 bar. Therefore, the decimal expansion of 3 by 7 is equal to 0.428571 bar. Now, the decimal expansion of 4 by 7 is obtained by multiplying 4 with 1 by 7. That is, we multiply the decimal expansion of 1 by 7 with 4. That is, 4 times 0.142857 bar. This gives 0.571428 bar. Therefore, the decimal expansion of 4 by 7 is equal to 0.571428 bar. Now the decimal expansion of 5 by 7 is obtained by multiplying 5 with 1 by 7. That is, we multiply 5 with the decimal expansion of 1 by 7, which is 0.142857 bar. So 5 times of 0.142857 bar gives 0.714285 bar. Therefore, 5 by 7 is equal to 0.714285 bar. So, the decimal expansion of 6 by 7 is obtained by multiplying 6 with 1 by 7. That is, we multiply 6 with the decimal expansion of 1 by 7, which is 0.142857 bar. So 6 times of 0.142857 bar is equal to 0.857142 bar. Hence, the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are obtained without doing the actual long division. Now let us move on to the third question. The question is, express the following in the form of P by Q, where P and Q are integers and Q is not equal to 0. So let us move on to the solution. The first decimal expansion given is 0.6 bar. Let us assume x is equal to 0.6 bar, which is 0.666 so on. Let this be equation 1. Since in the given decimal expansion one digit is repeating, we multiply equation 1 with 1 followed by 1 0. This is 10 times x is equal to 10 times 0.6 bar. This gives 10x is equal to 6.6 bar, which is 6.666 and so on. This can be written as 10x is equal to 6 plus 0.6 bar. Consider this as equation 2. Now we shall subtract equation 2 and equation 1. So 10x is equal to 6 plus 0.6 bar minus x is equal to 0.6 bar. So we have 10x minus x is equal to 9x, and here the 0.6 bar gets cancelled and we are left over with 6. Therefore 9x is equal to 6 gives x is equal to 6 by 9. Since 6 and 9 are multiples of 3, we cancel out the common factor and we are left over with 2 upon 3. Therefore, the p by q form of the given decimal expansion 0.6 bar is 2 upon 3, where 2 and 3 are integers and the denominator is not equal to 0. Now let us move on to the second bit of the question. So the second decimal expansion given is 0.47 bar. So we shall assume the given decimal expansion as x. Therefore x is equal to 0.47 bar, which is 0.477 so on. Consider this as equation 1. Since one digit is repeating in the given expansion, we multiply equation 1 with 10. That is 10 times x is equal to 10 times 0.47 bar. This gives 10x is equal to 4.7 bar. This is 4.777 so on. Here 4.77 so on can also be written as 4.3 plus 0.477 and so on. So this is 10x is equal to 4.3 plus 0.47 bar. So now from the obtained equation we shall subtract x from both LHS and RHS. So now 10x minus x is equal to 4.3 plus 0.47 bar minus x. So we have 10x minus x is equal to 9x, which is equal to 4.3 plus 0.47 bar minus x is equal to 0.47 bar from equation 1. Therefore 9x is equal to 4.3. Hence x is equal to 4.3 by 9, which is 43 by 90. Therefore the p by q form of the given decimal expansion 0.47 bar is 43 by 90, where p and q are integers and q is not equal to 0. Let us move on to the third bit of the question. The third decimal expansion given is 0.001 bar. So we shall assume x is equal to 0.001 bar, which is equal to 0.001, 001 and so on. Consider this as equation 1. Since in the given decimal expansion 3 digits are repeating, we shall multiply equation 1 with 1 followed by 3 zeros, that is 1000. Therefore, 1000 times x is equal to 1000 times 0.001 bar. This is 1000x is equal to 1.001 bar. This can be written as 1000x is equal to 1 plus 0.001 bar. Consider this as equation 2. Now let us subtract equation 1 from equation 2. Therefore, 1000x is equal to 1 plus 0.001 bar minus x is equal to 0.001 bar. 1000x minus x gives 999x is equal to, here we are left over with 1. So 999x is equal to 1, which implies x is equal to 1 upon 999. Therefore, the p by q form of the given decimal expansion 0.001 bar is 1 by 999, where 1 and 999 are integers and the denominator is not equal to 0. Now let us move on to the fourth question. The fourth question is express 0.999 so on in the form of p by q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. So let's go for the solution. So now we shall express the given decimal expansion, that is 0.999 and so on, in the form of p by q. So let us assume x is equal to 0.9 bar. Consider this as equation 1. Since in the given decimal expansion one digit is repeating, we shall multiply equation 1 with 1 followed by 1 0, that is 10. So we have 10 times x is equal to 10 times 0.9 bar. This gives 10x is equal to 9.9 bar. This can be written as 10x is equal to 9 plus 0.9 bar. Consider this as equation 2. Now we shall subtract equation 1 from equation 2. That is 10x is equal to 9 plus 0.9 bar minus x is equal to 0.9 bar. 10x minus x is equal to 9x, which is equal to 9. Therefore, we have 9x is equal to 9, which implies x is equal to 1. Therefore, the p by q form of the given decimal expansion 0.999 and so on is 1. We can also say by observation that 0.999 and so on is approximately equal to 1, which is a rational number. Now let us move on to the sixth question. The question is, look at several examples of rational numbers in the form of p by q, where q is not equal to 0. P and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? The property that q must satisfy in the order that the rational numbers in the form of p by q, where p and q are integers with no common factors other than 1 having terminal decimal representation, is that the prime factorization of q has only powers of 2 or powers of 5 or both. That is, q must be of the form 2 power m times 5 power n, where m is equal to 0, 1, 2 and so on, and n is equal to 0, 1, 2 and so on. Now let us move on to the 7th question. The question is, write 3 numbers whose decimal expansions are non-terminating, non-recurring. So let's move on to the solution. We know there are infinite numbers whose decimal expansions are non-terminating and non-recurring. So we need to write 3 of them. So 0.03, 003, 0003, and so on. So this decimal expansion is non-terminating and the digits are non-repeating. Let us also write another number whose decimal expansion is non-terminating, non-recurring. 0.07, 007, 0007, and so on. And another number whose decimal expansion is non-terminating and non-recurring is 0.05, 005, 0005, and so on. In all the 3 decimal expansion we have written, the digits are non-repeating and the decimal expansion is non-terminating. Now let us move on to the 8th question. The question is, find 3 different irrational numbers between the rational numbers 5/7 and 9/11. So let's move on to the solution. So the given 2 rational numbers are 5/7 and 9/11. So to find 3 different irrational numbers between 5/7 and 9/11, let us first find their decimal expansions. So let us consider 5/7. So we divide 5 with 7. Therefore, 7 is the divisor and 5 is the dividend. 7 does not go in 5. Therefore, we take 0. 7 times 0 is 0. So 5 minus 0 is 5. Since 7 does not go in 5 again, we take a decimal point and now 5 becomes 50. 7 goes in 50 7 times. So 7 times 7 is 49. And we are left over with 1 as remainder. Since we have taken the decimal point, 1 becomes 10. 7 goes in 10 1 times. The remainder we get is 3. Since we have the decimal point, 3 becomes 30. 7 goes in 30 4 times. 7 times 4 is 28. The remainder is 2. So because of the decimal point, 2 becomes 20. 7 goes in 20 2 times. So 7 times 2 is 14. The remainder is 6. So because of the decimal point, 6 becomes 0. So 7 goes in 68 times. So 7 times 8 is 56. So now we have the remainder 4. Since because decimal point, 4 becomes 40 and 7 goes in 45 times. So 7 times 5 is 35 and the remainder is 5. So from here, the remainders repeat themselves. Therefore, the decimal expansion of 5/7 is equal to 0.714285 bar. So now let us find the decimal expansion of 9/11. So here 9 is divided by 11. Therefore 11 is the divisor and 9 is the dividend. Since 11 does not go in 9, we take 0 as 11 times 0 is 0 and the remainder is 9. Since 11 does not go in 9 again, we take a decimal point. Therefore 9 becomes 90. 11 goes in 98 times. 11 times 8 is 88. The remainder is 2. Since we have the decimal point, 2 becomes 20. 11 goes in 21 times. So 11 times 1 is 11. Now we are left over with the remainder 9. So from here, the remainders repeat themselves. That is, because of the decimal point, 9 becomes 90. And 11 goes in 90 again 8 times. 11 times 8 is 88. Again we are left over with 2 as the remainder. and so on. Therefore, the decimal expansion of 9 by 11 is equal to 0.81, 81 and so on, that is 0.81 bar. Therefore, the decimal expansions of both the rational numbers 5 by 7 is equal to 0.714285 bar and 9 by 11 is equal to 0.81 bar. Now we need to find three different irrational numbers between 0.714285 bar and 0.81 bar. These three different irrational numbers can be 0.75, 075, 0075 and so on, as here the decimal expansion is non-terminating and the digits are not repeating. So we can consider another example for the irrational number between the given two rational numbers, that is 0.76, 076, 0076 and so on. And the third irrational number can be 0.78, 078, 0078 and so on. Hence these three can be the three different irrational numbers between the given rational numbers 5 by 7 and 9 by 11. Now let us move on to the ninth question. The question is, classify the following numbers as rational or irrational. So let's move on to the solution. So we take the first bit. So we need to classify whether square root of 23 is a rational or irrational. The decimal expansions of those numbers which are non-terminating and recurring or terminating are called rational numbers, and the decimal expansions of those numbers which are non-terminating and non-recurring are irrational numbers. Since here 23 is not a perfect square, the decimal expansion of square root of 23 is non-terminating and non-recurring. The decimal expansion can be found out using the long division method. So when we we obtain the value square root of 23 is equal to 4.795831.523 and so on. Here the decimal expansion is non-terminating and the digits are not repeating. Therefore, square root of 23 is an irrational number. Now let us move on to the second bit. So here we need to classify square root of 225 is a rational or an irrational number. Here 225 is a perfect square. The decimal expansion of square root of 225 is terminating. Therefore, let us find the value of square root of 225 using the long division method. Now let us place bars on each pair of digits starting from the left. So we have obtained two pairs, one is 2 and 25. Now the nearest square for 2 is 1, since 1 times 1 is 1. So now the remainder is 1. Now we bring down the next pair, that is 25. Therefore the new dividend is 125. To obtain the new divisor, we shall double the quotient, that is 1 becomes 2 with a blank beside it. Now we shall think of a number such that the new divisor multiplied with the digit gives a number which is less than or equal to the new dividend. So such a number is 5, since 25 times 5 is equal to 125, which is exactly divisible. Therefore 25 times 5 is 125. Therefore the remainder is 0. Hence the long division stops here. Therefore square root of 225 is equal to 15, where 15 is a rational number. Therefore square root of 225 is also a rational number. Now let us move on to the third bit. Here we need to classify 0.3796 is a rational or an irrational number. A number whose decimal expansion is terminating or non-terminating but recurring is a rational number. A number whose decimal expansion is non-terminating and non-recurring is an irrational number. So here the decimal expansion given is terminating decimal expansion. Therefore 0.3796 is a rational number. Now let us move on to the fourth bit. Here we need to classify whether 7.478, 478 and so on is a rational or an irrational number. A number whose decimal expansion is terminating or non-terminating but recurring is a rational number. Whereas a number whose decimal expansion is non-terminating and non-recurring is an irrational number. Here the given decimal expansion 7.478, 478 and so on is non-terminating, but the digits 478 are repeating. Therefore this comes under non-terminating but recurring. Therefore 7.478, 478 and so on is a rational number. Now let us move on to the fifth bit. Here we need to classify whether 1.101, 001, 0001 and so on is a rational or an irrational number. The number whose decimal expansion is terminating, non-terminating but recurring is a rational number. Whereas a number whose decimal expansion is non-terminating and non-recurring is an irrational number. In the given decimal expansion, the decimal is non-terminating and also the digits are not repeating. Therefore, this comes under non-repeating and non-recurring. Therefore, 1.101, 001, 0001 and so on is an irrational number. A number whose decimal expansion is terminating or non-terminating but recurring is a rational number. A number whose decimal expansion is non-terminating and non-recurring is an irrational number.